Our journey begins as dramatic and sudden changes are sweeping over the land. The approaching storm may seem violent and destructive to us, but to nature, it's a new beginning in the cycle of life. Surface of the land, roots trap water in the flow of life, extracting precious nutrients and minerals. These elements, when combined with sunlight, create the diverse living systems of our planet. One of those living systems is the rainforest, home to the most amazing concentration of life on our planet. These dense and beautiful forests cover only a tiny portion of the Earth's surface, but they contain more than half its plant and animal species. Rainforests are extremely rich and productive living systems, providing us oxygen, food, medicine, and other elements essential to our lives. In deserts, nature has created a very different but no less beautiful living system. And while this arid landscape may seem lifeless, it is very much alive. The plants and animals that have learned to survive in these harsh conditions make use of what little water they can find and avoid the scorching rays of the sun. Once appeared as desolate as the desert, but over time, rainwater and nutrients gradually penetrated the hard surface of this land. Even the hooves of the mighty buffalo helped create the rich soil that would one day become home to the American farm. Of all the forces at work on the land, humans have had one of the most profound effects. The need to produce food for a growing world led to the enormous use, and sometimes overuse, of the land. In our search for more efficient ways to grow food, we often fail to realize the impact of our methods. Today, we're learning to live with the land, discovering better ways to grow food that will assure both human and environmental well-being. In farmlands across America, we're learning that by plowing under vegetation containing natural fertilizers, we can enrich the soil without the use of chemicals. In Saudi Arabia and Mexico, we're learning to produce food on desert seacoasts by developing and planting crops that thrive on salt water. Here at Epcot, we're learning to reduce the need for pesticides by using natural predators like ladybugs and wasps to control pests. In Japan, we're learning by adding how will we meet tomorrow's growing needs for food production, yet still respect the needs of the land? Some of the answers are being discovered just ahead.
Hi, hello again, everyone. I want to welcome you to all the most innovative and exciting areas of Epcot, where researchers and scientists from Nestle and other organizations are trying to develop better ways of creating better quality foods. As world population increasing, techniques for growing foods is changing. You see examples of growing techniques here today in our greenhouses. The first one we're approaching is the tropical greenhouse, where some of the world's most important food crops come from. On your left and right side to begin with is the cacao plants, a food source for chocolates. These fruits, we have some of them over here on your right side. They're not ripe yet, but with butter and sugar they make chocolate. To save some valuable space, we have sweet potatoes growing underneath them. This method of growing is intercropping, growing 2 crops in the same area to save space. Shavings of the papaya fruits on your left side, just the green ones, can make papa, which is made into a meat tenderizer. And as our growing media, we're using sterilized sand in the greenhouses. Sand doesn't hold any nutrients in it, but as long as the plants receive water and nutrients, and it does by drip irrigation, they can grow pretty well in it. On your right and your left side of the terraces, we have rice and peanuts. Rice is harvested just like wheat is. You can see the tops of them. Peanuts are planted first because it leaves behind nitrogen, then the rice is planted next. This growing method is called crop rotations. One's fertilizing the other crop. Also on your right side is sugar cane. Every cane produces 30 teaspoons. The remaining cane can be used in the processing of it. And on your left side, the peach palm trees. One of the palm trees only has very sharp needle-like thorns on it. Very nutritious foods also can be used like cooking oils. Native to Costa Rica. On your left side, the cassava plant has a starchy root to it. That's where your tapioca comes from. The vine plant on your right with the yellow flowers on its lufagard, a vegetable sponge, and surrounding us the greenhouse is bananas. Since Florida doesn't have any freezes, we can grow bananas. They're not trees or plants, just made of compressed leaves. They require lots of water and they love fertilizer. But after the batch has been harvested, the plant needs to be cut down to the ground level. New ones will start growing and replacing them. They just keep multiplying. Coming up next, rendering is the aqua cell. These are farm-raised fish from the table. Many parts of the world are producing fish this way, especially deserts. On your right, the pacu fish, a cousin to the piranha. It's a vegetarian fish that's low maintenance and high in protein. The next takes us tilapia. They're in their natural habitat, being close together like they are. They make good fillets. About every 3 to 4 pounds of food they eat in a year's time, they gain a pound. Channel catfish also on your left side. And on your right, we have the American alligators. No longer endangered species, Florida has over 1 million of them. Right now, they're just a few months old, and we can hold about 56 of these baby alligators in these tanks when they're this young. But some places we meet times we just have them for show. In the tanks here, we've got eels in the middle tanks, clawfish in the top tanks, and freshwater shrimps are on the bottom. See the ones with the blue claws on the shrimps? Those are the male shrimps. The other ones are the female shrimps. Shrimps and clawfish territorial. We only put a few in each tank, so they tend to find out the spaces. As for the eels, about every 3 to 4 pounds of food they eat in a year's time, they gain a pound. Coming up next in our temperate greenhouse, rendering is our we have an irrigation control system that does our watering for us by drip irrigation. Instead of taking like a garden hose and soaking everything down, you're using more water than needed. Drip irrigation just waters the plants individually, and it saves as much as 60 up to even 70% on watering. This over here on your right side is our lemon tree. Sometimes you can actually propagate them. These lemons are ponderosa lemons. They weigh as much as 9 pounds. Same with the pomelos and grandfather to grapefruits. Cotton plants takes 3 months to flower. 2 months after it flowers, it produces cotton. Actually, it originates from Arabia, brought here in the 1700s. On your right side, sorghum used to make molasses. Clovers underneath it gives the nitrogen. And on your left side, a good firewood is Leucaena trees, just a long-elasting wood burner. This greenhouse we're coming up to next is our production greenhouse. Some of the media we're using here is coconut coir. The outer shell of the coconut, kind of like a peat moss, it retains moisture. Growing the cucumbers vertically over here on your left side, these young plants. But as they grow, they'll be tied along the strings and they'll grow straight up to the top. Going up vertically this way makes it easy to check for insects, makes it also easy for airflow here in the greenhouses. On your right and left side, these vine plants is malabar. It's a tropical plant that's native to Indonesia that grows over 15 feet tall. The leaves can be eaten like lettuce, cooked like spinach, the berries can be used as dyes, and the tops eaten like asparagus. So much for one plant. Underneath the lettuces are growing on these styrofoam panels. They just float on water. This is called hydroponics. Over here on your right and left side, we have is eggplants and peppers. Now, 35% of the world's crops are destroyed by insects each year. Through genetic engineering, plants like these are being experimented on to carry a genetic gene inside of them where the insects won't bother them. They'll move on to something else. Need those instead. Kind of a new technique to reduce these pesticides by as much as 60%. There's always a natural way of letting loose ladybugs eat the aphids. Now coming up over here on your left side, we're going to offer energy. This roller here has a video camera to it. The video camera uses a spectrometer, thermal infrared sensor to measure the stress level on plants and how sunlight affects it. It tells if the plants are getting too much little sunlight by color changing the leaves. This greenhouse we're entering is the creative greenhouse. In this greenhouse, everything is growing without soil. This is called aeroponics. Allowing air exposure to the roots allows for a stronger and healthier root system and helps the plants grow a little faster. Good idea. A good example of these, like the squashes here on your left and right side. They're on these long hooks so they can grow along them and helps it support its weight from the vegetable it holds. It rotates around that wall, and inside it gets water and nutrients, and it gives us air exposure afterwards. As you can see, it allows a stronger and healthier root system. On your right side, this is our biotechnology lab, where research is being done on genetic engineering, plant propagating, and tissue sampling of plants, and lots of record keeping of what goes on back here. And on the left and right side, NASA is experimenting to see how plants can grow by recycling air and water from waste products, or perhaps later on, future space colonies. So as you can see, there's lots to learn between nature and science with looking at the land. The laboratories that you just seen today was just part of the story. And once harvested crops are carefully handled from the fields to your table. When we grow in our greenhouse, we do put them to good use. Most of it we send it to our own restaurants. A lot of it goes upstairs to the garden grill. And also we do offer one of those behind-the-scenes tours as well in the greenhouses. You can go on a walk through the greenhouses. It runs about an hour and a half long. And the last time I signed up for it's at 4:30 at the gift shop downstairs. This way you get more of a better idea of what goes on back here. But all in all, throughout our greenhouses, though, we're mixing nature and science to create better quality tasting foods. And researchers from Nestle and other organizations are trying to develop better ways in creating better quality foods. So for all of us to work together with other countries and cultures around the globe, not only we can preserve our natural resources, but also meet the needs for the growing demands for better quality tasting foods for a growing world's population to enjoy them. And then we'll all be living with the land.